than a minute.
She has what?
Less than a minute.
Are we making pizza? Making pizza?
Yeah.
Oh, it smells so good.
I got the pizza cutter and everything over here.
Am I bringing your pizza over here?
Well, we got time to. I'll just talk about pie for a minute.
We're live at 3:14.
Which is right now.
Okay.
You're live.
All right, breaking news, everyone. It is Pie Moment on Pie Day, which is 3.14, etc., etc., etc. And I just want to take a moment to say that this breaking news is brought to you by Raphael's Bakery just down the street. They have so generously donated a pie. Let's see what it. I'm super out of breath because I'm running around. Oh, I have never seen a prettier pie. Once again, this beautiful, looks like lemon meringue, has been generously donated to us by Raphael's Bakery. So they're not actually open today, but if you would like to celebrate pie on any day, we highly recommend going and checking out Raphael's Bakery. All right, so I'm gonna set that aside for just a moment. I'm gonna catch my breath. All right, so what is pie? Now, when we say pie, when I say pie right now, I'm not talking about delicious lemon meringue or fantastic pizza pie. What I am talking about is the 16th letter of the Greek alphabet, which is the ratio of the circumference of a circle to its diameter. All right, so pi is what we call a mathematical constant. It is a number that does not change. Another mathematical constant that we might be familiar with is the golden ratio. So that is a plus b over a equals a over b. And it's got that another fun little Greek letter there. So this is just an example of another mathematical constant. All right. So the distance around a circle is roughly 3 and some distances across. Pi is what we call a rational. Come on over, check it out. Pi is what we call an irrational number. So that means we can't express it as a regular fraction. So a fraction being like 1 over 2, right? If we divide that, we get a decimal, 0.5, and that decimal ends. If we try to make, so basically pi is a decimal that repeats and goes on, and it never repeats, but it goes on and on forever. So let's see. The world record so far is held by a man named Rajveer Meena over in India, and he has memorized pi to 70,000 digits. So when he recited the numbers blindfolded, and he recited 70,000 digits. The unofficial record is 100,000 digits. All right, so the ancient Babylonians, about 4,000 years ago, they came pretty close to an approximation of pi. They came out to 3.12. A little later, the Egyptians kind of came close again. They got 3.16. Let's see. Around 200 BC, Archimedes figured it out, kind of in relation to a parallelogram, and a parallelogram is like a rectangle that's been kiltered onto its side. Pi, as we know it, didn't really exist until about 1706, and a gentleman named William Jones is the one who decided to use the little, the symbol that we all think of, and a gentleman named Leonard Euler, but it's not spelled like oil. He made it really popular. He's a mathematician who has done a lot of stuff. All right. So, what can we do with pi? So earlier I said that pi is the ratio of the circumference, which is around, and the diameter, which is across. So if we were to measure, let's see, this pie is so fluffy. Can I have a pizza delivered to my pie table? I would be ever so grateful. I know. So what we're gonna do is we're gonna measure around the circle. So I'm gonna use some yarn, and I'm gonna cut this chunk off, but it's coming from the inside, so I'm just gonna assume that it's pretty clean. All right, thank you so much. So I'm gonna use a piece of string to get a nice measurement of the circumference, which is around. All right, so it's really difficult to do that with a ruler, a straight edge, so I'm gonna use string. And like I said, the string's fairly clean. So we're gonna go around here. My lovely assistant, Tara's gonna help me hold. So Pi Day was started in 1988 at a science museum called the Exploratorium in, I think, San Francisco. So they started it as a way to sort of celebrate and increase interest in math. All right, there we go. Okay, so here is my length around. So I'll measure this very quickly. 12, 24, 36, we'll say that that's about 36.5. All right. So I'm going to pull out my super fancy calculator.
Not 36.5. It's 36 and then another half foot is what you're saying?
Oh yeah, so 46.5, sorry.
Would you like a ruler?
I'm sorry, what?
A ruler. Not a stick.
That would be easier. 6.5. All right, so now I'm going to use this. Okay, so there's my 12 inches plus 14. 14. All right, so I came really close. I got 3.12, and probably what happened is my string is a little bit stretchy, and I'm eyeballing it. All right, so I went around, and we got 46.5 inches, and we went across, and what did I say? We got 12, 14, 13 and a half. All right, so there we got pretty close to pi on our pizza pie. Not exact, again, because of human error. And you know, our pie is not perfectly circular. We got some bumps and lumps and doodads, but it's pretty close, especially considering the inaccuracy of our tools. So let's try another pie. This one's a little bit smaller, and this one's going to be a little more difficult to get a good.
So far, so good. Good job.
Oh, I cannot wait to finish measuring our pies so we can eat them.
That's right.
Pretty close. Okay. So now we'll try this one and see what we get. And all right, this is gonna be even less accurate because I'm eyeballing it. We don't want to wreck that beautiful meringue. I mean, so I'm gonna say that's about 8 8 1/4. So I suppose we should measure that. Here we go. All right, so our lemon meringue pie has a circumference of 29 inches divided by, what did I say, 8 1/4?
Yeah, 8 1/4.
Equals, so again, we're a little off. I got 3.5. And that's, again, because I'm eyeballing this and that and the other thing. So the trick is, if you want to get to 3.14, you do have to have accurate measurements. It's not going to work if your circumference isn't quite right. Let's see, what else can we measure? Oh, let's measure, let's find pi of an actual single pepperoni, eh? Why not? This one will be nice and easy because I can hold the string with my fingers. And even though I cleaned the table really good, I'm not going to eat this pepperoni. It's probably going to be full of hair. All right. So our pepperoni is 6 inches. I'm gonna say 6.5 inches divided by 1 3/4. 1.75.
There's standard size for a pepperoni.
We have standard pepperoni only.
I think this is fairly standard. All right, so that was, again, still pretty far off. So that was about 3.6.
This one's really uneven.
Yeah,
Good try.
we got a little baby pizza over
This is
there.
not pie's fault.
This
Pie
is
amazingly
one.
robust.
This is 100% operator error. 100%. Pi has been pi for 4,000 years. My inability to take an accurate measurements by no means does that
Right.
make pi any less cool.
I heard a Jay Wizard that
Let's
said
try.
you only need 6 digits of pi to accurately measure the circumference of the Earth at the equator. So it's quite robust, even with only a few decimals.
This is even trickier on this one.
Right. Inside.
Well, it makes sense that pi is so perfect and never ends because a circle is perfect.
It
It's
is.
the perfect efficiency of area.
This is tricky.
Yeah, we're gonna just
I wonder if
say.
we could.
Let's try it a different way. Let's find our circumference and multiply it by pi, and then, or wait, how's it go? We can find our circumference pi times diameter. So if we go pi times
Same.
7,
Yeah, I don't know why we didn't get that. We just
7
work in
times
ours.
0.15
The
equals.
center's more predictable, maybe.
So this should work out to about 22 inches around. And so we're just gonna eyeball it because our string. How many scientists does it take to measure a pizza?
About as many as it takes to eat it, so
Right.
that's why you get this many.
Okay. Let's see how big this is. Let's just check it and see. Can I see the yardstick?
So after my extensive research with this pepperoni, I determined it's not entirely perfectly round.
Oh, sure. Yep.
Oh, is it perfect pepperoni?
All right.
Research.
So a really, really loose measurement came out to 23 inches, which is only an inch off of what it should be if we were doing it accurately. All right.
Nice.
What, and did we mention it's Einstein's birthday today?
It's also Einstein's birthday.
Yes, so we want to celebrate one of our heroes too on pie.
So we've got a pie for birthday, a pie for birthday.
That's high for lunch.
All right. Anything else? Pie related?
Well,
I've got my
skies
very,
that
very
went,
greasy
Let's at the very least stay live for another 2 minutes so that all of our viewers who tune in at 3:30 for the normal time
Sure.
can at least be told what's happening.
All right, I'm gonna, let's see here. So this is a 14-inch. So let's find area.
We could do it in the metric system and see if we get more accurate.
Well, that's true.
Sure, you do have centimeters on the other side of that stick.
Times. Okay.
That would give us 2 minutes for the air.
Okay, so do you want me to re-measure with the string? Go back around and measure it with.
The other thing we could try is something probably a little bit more predictably circular.
Right.
Something not sort of lumpy by design.
I'll get on camera with you.
The thing about
The start
circles.
point, and we hold the start point, and then we're going to try a better stretch. We're going to do a stretch measurement, and I'm holding the start point over there. We're still good at. Oh, we're sliding.
It's not.
This is why we like pi, because
Right.
it's so
Pi
perfect.
means we don't have to do this. We can just
We trust pi. We might be into a
Yarn
third.
obviously not the
Let me get my finger there.
not the most reliable material as far
It's
as
stretchy.
not stretching.
It's
Your
all
other
right.
hand is free. There you go.
Okay, so this is our plate.
We should get a good measurement on this side, because we have a diameter line, and we should be able to get an R out of that. We've got a center. We've got a center point. We've got 30.7 centimeters. So
Is that 1 foot? Is that how big that plate is?
what does it claim to be?
Is it supposed to be exactly a foot?
Maybe. Is that what a foot comes to?
Pretty close. I don't know.
Yeah, well, let's try it on the other side. Well, according to this, it's a little bit bigger than a foot.
Okay.
Okay, so let's measure on the
So
on this
there's
side
our
to make sure that we're not using
our circumference.
an imperfect measure. I will go down to 0 with this.
And then we're gonna stretch it. Yeah.
I'm not on 0 quite. Here I am. Okay, no, I am.
Alright, so we got 98.2. No, it's the other way. 98.2 divided by 30.7 is 3.19.
We're getting better.
That's
We're
real
getting better.
close.
We like the metric system already.
Yeah, can this just be a PSA to, can we please switch to metric? United States, can we please get on the
Please,
bus?
let's do it. Let's do it. I'm ready.
But then you'll have to go to the sandwich store and get a 30-centimeter long
That's
instead
okay,
of a foot
but
long.
we get to drive 100 kilometers per hour, though.
Right? Alright, I'm gonna start cutting our pizza. So here we have,
Our outdoor temperatures will be within 10 degrees of each other all year.
There's a disappointment there. 30 is good and all darn hot.
let's see, I'm trying to remember my pizza slinging days. Alright. Now, one thing we could talk about is if we take a circle and if we set them like this, make my table all greasy, we get what's pretty close to a parallelogram, which is much easier to measure the area of than a circle. And the parallelogram is how Archimedes figured out how he got to his version of pi. So that's the visual that I learned in elementary school, except we didn't get actual pizza. So I'm living vicariously. So we can have pizza for lunch and delicious Raphael's pie for dessert. Did I mention how amazing it is that Raphael's gave us delicious pie for free? I'm just gonna keep saying that.
Got a comment on Facebook that says, what if we try it with the circumference of somebody's head?
Ooh, so
Who's got the roundest
most
head?
heads are kind of, I would say, oblong, but you
Will you volunteer your head, Brian?
No.
Whose head is
Could use.
Okay, well, it's her head. She's head appropriate.
I don't think that heads are very circular though.
No, they're not. Hard to get a diameter on probably too.
Well, what if we find out how far to
Yeah.
the center of our brain? Even that would be it.
Who has the roundest head?
There we go. That's a YouTube video. We get
could make?
figure out who has the roundest head here.
And we do it like the opposite, right? Whose ratio comes closest
Yeah. Who's
to
ready
3
pick?
point?
Yeah.
There we go. Because the farther off, the less round you are. So one cool thing about pi, and I guess sort of math in general, is when you have things like this, where it says pi times r squared, if you know one number, you can figure out other ones. So if we don't know the radius, well that one, but we know the area, we can figure out the radius through pi and all that sort of thing. Same with circumference and diameter. If you know the diameter, if you know the circumference, or if you know the diameter but not the circumference, you can use pi to figure that out by division and all that fun stuff. So a little shout out to math, doing its thing, making life easier. Sort of the unsung hero.
It's the original science, mathematics.
It's, you know, a lot of people call it the language of the universe. I don't speak the universe, so I don't know it.
It's the international language, I would say, mathematics. Nobody's
Yep,
changed
mhm.
it for their own.
Almost timeless,
And
you know. People been
and we'll continue with the same similar mathematics into the future, we believe, with some better functions to go along with it.
A lot of talk about the Perseverance, the most recent rover. Also, the parachute is very fancy. It's got a bit of a code written in there, but NASA popped onto the internet actually yesterday, talking about how they use pi to figure out how large to make their parachutes.
Cool.
So, you know,
NASA crew, they're a fun bunch, NASA.
they're very
fun
yep,
scientists.
Good at math as a collective.
right. Yeah. Yep.
Hot take: NASA knows math.
Yeah. Definitely.
But
Salud.
Cheers.
Yeah. Pizza.
thanks for watching, everybody. So we started a little early today because it's Pi Day, so we wanted to get started at our 3:14 time slot, or 3.14. But going forward, we'll be back to the 3:30. So have no fear, we're not changing everything on you for the future. Today was just a special case in celebration of Pi Day
And Einstein's birthday.
and Einstein's birthday. But Science Center is open right now. You can come and visit us on Friday, Saturday, Sunday, and Monday. Friday, Saturday, Monday, we're open 9:30 to 5:30. Sunday, we're open 1 to 5:30. We do have some restrictions still in place because of COVID, but we'd still love to see you come in here. And if you happen to be here at 3:30, you might be able to participate in one of these shows, which is good for us and